Everyone, today I will discuss totally about the wave function used in quantum mechanics. The wave function representation of the wave associated with the particle is in motion. The position any time of any moving particle within the wave packet is described by is represented by a function is known as wave function and it is represented by psi. It may be real or complex. The wave function represents the position of the particle within the wave packet and their maximum value represents the amplitude of de Broglie wave. If we multiply the wave function with their conjugate psi star, then it will represented by psi mod square and it represents the probability density of finding the particle within the wave packet. It is given by max bar. So psi mod square represents the probability density of the particle. If we take the product of charge and q mod square, then it represents charge density. These are the definitions of wave function and their physical significance. Properties: wave function may be real or complex. Wave function must have single values. Wave function always have finite values. Wave function tends to 0 if x tends to plus minus infinity. It is just like in ordinary wave, we always get a node at x is equal to minus plus infinity. At the node, the displacement is 0. So in this case, at infinity, the wave function vanishes. Next property, normalizing and orthogonal. Very important property of the wave function. If we multiply psi with their conjugate psi star and taking integral within given limit, and you will get the value of 1. That means total probability of finding the particle in the given place is 1. Then our wave function psi is called normalized wave function. So with normalized wave function, total probability is equal to 1. If our wave function is not normalized, but if we take the product of the wave function with any number n such as n psi and it is normalized, then we apply the condition integral n psi star n psi d tau is equal to 1. So we will get the value of n by this formula is called normalizing constant. Such value, if we multiply the given function, then the final function with product with normalizing constant n will be normalized. and gives probability density 1. Probability 1. If the two wave functions psi1 and psi2 are such that they follows the property integral psi2 star psi1 d tau is equal to 0, then they are called orthogonal wave function. So one condition psi2 star psi1 d tau is equal to 0 is orthogonal and is equal to 1 is normalized if the wave function are same. So these two conditions are written in the general form psi n star psi m d tau is equal to Kronecker delta mn. If m is equal to n, then its value is 1. If m does not equal to n, then its value is 0. So this formula is called orthonormal formula, orthonormal property. It is written in bracket notation n m is equal to Kronecker delta nm, or psi n psi m is equal to Kronecker delta nm. Now take some example related to normalizing property. My first example, to normalize the wave function psi is equal to n e to the power minus x square upon a square plus I k naught x. Then find the normalizing constant n. So the given function is this. Now take their conjugate. I is replaced by minus I. Now apply the normalizing condition psi star psi dx is equal to 1, and if limit is not given, then our wave function vanishes at x tends to plus minus infinity. So apply this formula, then you will get this formula, and apply a property of definite integral minus infinity to plus infinity e to the power minus alpha x square dx is equal to under root pi by alpha. So the normalizing constant is this, n is equal to 1 upon a under root pi by 2 power 1 by 2. Second part of the problem, the region in which probability is maximum. Which value of x at which probability is maximum. So value of x is 0. If we take x is equal to 0, then psi star is n mod square. This is a maximum value because e to the power minus x square by a square. The lowest value of x for x square x is equal to 0. So at x barabar 0, we get maximum probability density. Their value is this. Now take another example. The wave function of particle in a box is given by this. Psi is equal to sine pi x by L. Normalize the wave function for x barabar 0 to x barabar L. Now multiply this wave function with a normalizing constant n. So phi is equal to n psi, phi is equal to. Now apply the normalizing condition in the new wave function phi. So phi star phi dx is equal to 1, n star, and Sine square pi x by L is converted into 1 minus cos 2 pi x by L by 2, and integrating you will get the value of n is equal to under root 2 by L. Now putting in equation number 1, you will get the normalized wave function under root 2 by L sine pi x by L. This is the complete explanation of wave function and their physical significance, and some examples related to orthogonal and normalizing of the wave function.